Alright guys, here we go. Projectile motion, team sheet number 2. A rescue pilot drops a survival kit while her plane is flying at an altitude of 2,000 meters. So off the bat, we know an altitude of 2,000 meters. So you got a plane flying by. Okay. While her plane is flying with a forward velocity of 100 meters a second. So a forward velocity, meters a second, right? Okay, let's say she's dropping a survival kit. How far in advance of the starving explorer's drop zone should she release the package? So she's going to release the package. It's going to follow this horizontally launched projectile trajectory, curving downwards. Let's say she releases it right here. How far ahead of this starving explorer should she do it? Alright, so let's convert this to our favorite variables. You know, which of these variables are we given? We know dy. Our displacement in the y direction is 2,000 meters. We know our VIY, our initial y velocity, because there is no initial y velocity. It's horizontally launched. There's no vertical component. There's no y component of this initial velocity. So our VIY is 0 meters per second. What else do we know? We know our VI, our initial x velocity, our VIX, is 100 meters a second. Okay, what do we want to find? We want to find our dx, right? The distance horizontally that this package is going to travel before it reaches, when it leaves the plane, how far it's going to go. You want to know how early you need to release it to get to this guy, this starving explorer. So you need to find that. To find that, we're going to need t as well. We're almost always going to need to find t. So it's good to just kind of know that off the bat. Okay. How are we going to find t? This should be pretty familiar. Which of these formulas can we use to find t? It's this second formula here. Why can we use that? Because there's only one unknown. We know our VIY, we know our dy, we know g, and so t is the only unknown. And when there is one unknown, you can solve for it. So I'm going to write my formula. dy equals VIY times t plus 1/2 a or g t squared. Plugging in our values, 2,000 meters equals VIY is 0 meters per second, times t plus 1/2 negative 9.8 meters per second squared times t squared. Alright, this is actually negative 2,000 meters because it's down. So just taking away units so I can do math here. Negative 2,000 equals, this drops out to 0. 1/2 negative 9.8 times t squared. Doing math, we know 1/2 times negative 9.8 gives us negative 4.9 times t squared equals negative 2,000. We're going to divide both sides by negative 4.9 equals our t squared. Then we're going to have to take the square root of both sides to get rid of that square. And so we get, scrolling down just a little more, the square root of 2,000 divided by 4.9. Since they're both negative, that negative cancels out. Equals T equals, that's 408.1, actually I'm sorry, that's 20.2. 20.2. It'll take 20.2 seconds to fall that distance of 2,000 meters. Alright, so our T is 20.2 seconds. Alright, now that I have my T, right, and I have my Vx, I can use this dx equals Vx times T to solve for our dx. We know our Vx, we know our T. That'll allow us to find D. So scrolling down for some empty space. Dx equals Vx times T. Dx equals 100 meters per second times 20.2 seconds. Dx is, now we can see meters per second, meters divided by seconds, times seconds. Those seconds will cancel out, leaving us with meters, which is what we want. 100. I don't even need to use a calculator here because multiplying by 100, it's just going to move my decimal place over 2 to the right. So it's 2,020 meters. Right? We just went 1, 2 decimal places over. So the distance that package travels when released by this airplane is 2,020 meters, and therefore that's how far ahead of the Explorer the pilot should release this package. Alright, that's it for that problem, guys. Onwards.